Today's keynote is Caleb Sema speaking about unlocking the future. AI is the key to CISO's top challenges. Don't forget that you can ask questions via Slido at bcisf.org/Q&A. And without further ado, happy Cinco de Mayo, and welcome to the stage, Caleb.
Hello, everyone. Today, I will be giving a very positive and hopeful talk about AI and security. Isn't that a nice change, right, at a security conference? We will be focusing on real issues. I call them sort of the CISO's top challenges. We're going to do some predictions around how will AI hopefully help solve some of these challenges. So let's get started. First, I want to set up some basic AI fundamentals for everybody. I think we need to understand, to set the stage, to learn about what we're going to be talking about in order to make our predictions. Let's listen to a little bit about, hey, what are some of AI's strengths and some of their limitations? Now, what's really interesting about this is most people thought before and by the way, when I say AI, I mean specifically generative AI, and in this talk, specifically LLMs as AI. But what's interesting is, like, most people thought around AI, it would take all the menial jobs, very simple tasks, automation, and things like creativity, problem solving, really great communication, then synthesizing information would be the last kind of thing that any sort of AI would take. And what's fascinating is it is actually sort of the first thing that AIs actually have trended to be very good at. The limitations, of course, there are limitations, and this is really the view of AI as I think we see it today. Now, one of the best quotes that I think sums up all of this very simplistically is this quote that someone told me, which I think is very true. What is AI like? It's a genius 13-year-old who is overconfident with a short attention span and no street smarts. If any of you who do prompt engineering or work with AI, you're like, yeah, that pretty much sums it up. But that's pretty fantastic in the fact that, hey, this is an interesting thing that you can work with. So let's dig a little bit deeper in some of the fundamentals of AI. But in order to do so, first I need to give a little bit of an analogy around us, humans, and about how we think, or really how we learn things. And this is a very rudimentary, and I would say explain it like I'm 5 version of this. By the way, my daughter, who is 6, is also in the audience, and my son, who is 4. So let's see if this actually works. Okay, so let's think about how do we learn, let's say, a new skill. So I'm going to take an example like cross-site scripting, since it is B-sides. You want to learn about cross-site scripting. So what's the first thing you do? You start reading everything you can about it. You read the tutorials, go online, maybe do a little bit of labs, everything, different angles, different views, different articles. All of this is being processed by your sort of short-term memory. The more and more that you read, and the more that you go over it, and you iterate, and iterate, the more you're looking really for the principles, the foundations of what makes cross-site scripting a thing. At the beginning, they'll be very, very distinct. Oh, you can only do cross-site scripting in HTML and JavaScript, right? Like, when you're new, you just only go by what you have read. But after you do enough iterations, you start really condensing this down into what I call working memory. This is sort of like abstracting it just a little bit, synthesizing it just a little bit. Oh, cross-site scripting is about inputting something, getting it reflected back in some way, and then what can you do with that? And then over your iterations of time, let's say working memory, weeks, months, and months of studying cross-site scripting, you start gaining more specialized knowledge. So for example, if you think about over a year of really working on cross-site scripting, you can come to B-Sides and give a presentation as an expert on cross-site scripting. You've really become a specialized individual in your knowledge. And then after you do that enough times, over years and years of your knowledge, it actually becomes part of your foundational fundamental knowledge. I'll give you an example. Like, I've been doing security in over 20 years, right? It is part of my core. It is part of my foundational knowledge. What does it mean? This means I can instinctively look at any new technology and any new thing, and you start seeing the patterns, and you start correlating, and you start saying, oh, this does this does this. You've got it to a point where it's become instinct. This is a little example, and again, very rudimentary, about how we might learn a new skill. So then your question is, well, Caleb, like, what does this have anything to do with AI? And let me get to that. Because LLMs today and AI today has some very similar patterns. Here's sort of how to think about this. Today, we have context windows or context memory inside of LLMs. This is the equivalent of short-term memory. It's our 64K of RAM is the equivalent, I feel, that we have today. And then we also use working memory, our sort of equivalent of working memory, what people are using is RAG, all right? So, or vector databases. This is where people are saying, hey, I don't have enough context window size, I'll save it into sort of my vector database, and then I'll be able to retrieve this information with some level of accuracy. And then people are now using, whether for wrong or for right, fine-tuning to start making this equivalent of specialized knowledge. Okay, if I take this open model, I fine-tune it, I can get a more specialized version, a cybersecurity expert, a cross-site scripting expert. This is how I'll do it. And then you've got your foundational knowledge itself, which of course is not trainable at all. So when you look at this, the difference, of course, is that each of these phases in AI today is very distinct and very manual. There is no carryover from context to RAG to fine-tuning to your foundational model. This does not happen. Everything is manual, everything is specific, and everything is done in a certain order in a certain way. However, when you start looking at where AI is going in the next year or 2 years, the goal is to go towards the way that we learn. So when you start thinking, how do LLMs or AI start learning on their own, you start thinking about things like, hey, continuous or constant fine-tuning. And what does that mean? Perhaps that means, similar to computers, is, hey, my short-term memory or my RAM gets a cache, which then may get saved to hard drive. And this happens automatically. And so when you start thinking, oh, as we move forward, does this goal start happening? This is the sort of things that we need to think about as we start making guesses and predictions around how it's going to affect cybersecurity. Okay, now we've got the fundamentals down. This allows us to make some predictions, and I actually wouldn't call this much predictions around AI itself. This is why I've titled this, What is Here Today, but is Coming Tomorrow, which is most of these things that I'm about to walk you through are actually here today. They're just not really disseminated widely, and they're not ubiquitously in our organizations. But everything that I talk about here, there is already research, discussion, and if not already, products that are executing on these things. So first, expanded context awareness. Today, we are working in terms of short-term memory, very small amount of memory. Really the equivalent of, again, like you think old back computer days, 64K of RAM. What we really want is we want 16 gig of RAM. And then how do we get that? Oh, don't mind my kids. I predicted 10 minutes, so this is about right. Bye, Neo. Okay, so think about context awareness. This is really key. Right, today we've got Gemini with 1 million token context or 1.5 million token context. But what we really need to start thinking is, what if you could have large amounts of windows? For example, could I pass in 1 gig of log data into my LLM and have it analyze this? This is really key because in order for LLMs to start processing real-time data, context windows will get bigger. Continuous self-improvement. This is what we sort of talked about previously. This model or thought about continuous fine-tuning. Okay. Bye, Ava. Continuous but I brought my kids because I don't think they know that I do anything. So this is like the example. They lasted about where I predicted. So think about continuous self-improvement. This is the ability to fine-tune or learn. So take, for example, the log when I'm processing real-time data. If I have an LLM where its prompt is, hey, you're processing log data, you need to look for these kinds of things. And I'm shoving gigs and gigs, and you're just constantly, this is the LLM's job, constantly looking at log data. why should it not start thinking about, oh, hey, I know what my job is, I know what I'm good at, I can start moving and freeing up my context window and start moving this into more generalized, specialized knowledge. And then when this starts happening automatically, it becomes really fascinating how LLMs will move forward. Third, localized intelligence. Models are getting smaller and cheaper all the time. You are already seeing this. Apple just released their models for what they're going to be doing for on-device models. You're seeing things that are, let's say 3 billion parameters or 7 billion parameters that are now the equivalent of 70 billion parameter models. These things are getting smaller, more efficient. They're going to be on your watches, your phones. And by the way, don't just think about consumer uses, think about enterprise uses. So if these models are local and small and efficient, they should be running in your containers. They should be running in Lambdas. Like, these things are going to start getting to the positions where they can monitor and look at things at much, much smaller and much more specialized scale. Which also leads to the next one, which is deciding and acting. Models right now, you see it's a lot of translation, it's a lot of creation, but when they start making decisions and acting and giving tools, so for example, if I give an AI/user bin, what happens? And by the way, to all of you guys who I know, this is a security talk, like all the fear, all that's coming in your heads, please keep it, I get it, but you have to understand this is coming. Right? So that is an entirely separate talk of how to secure these things. And then finally, low cost and high performing. Cost of these things, especially at inference, is going to be driven down drastically. Let me give you an example on high performing. Today, the cutting edge is around 600 tokens per second that you're going to get on an LLM. And that is by companies who make specialized chips for this. We know for a fact that in the next year or so, easily, these things are going to reach speeds at 100,000 tokens per second. So if you think about how instantaneous these things will perform, it becomes really thought-provoking around what can be accomplished. Okay, so now I've set sort of this base foundation. What is AI today? How can we start thinking about where this is going tomorrow? And now we need to think about, well, what will this enable the enterprise? What will this change when we think in the next couple years? First, we need to focus on the enterprise because we're security. Security is based on the foundations, and what will change in enterprise says what will change in security. So these are the things just off the top of my head that I believe will change in the enterprise as these things start happening. First and foremost, you know this in every enterprise, meetings is where decisions happen. This is 90% of how an enterprise makes decisions, where it goes, and its lifeblood is all based in meetings, for better or for worse. Nobody likes them, but that's the way that it works. But this thing, all meetings will be absolutely recorded, analyzed, and note-taked by AI. I have been using an AI note-taker for 6 months, and it is phenomenal. There is no doubt in my mind that in a year, every enterprise will mandate, or at least just from most meetings, that these note-takers will be present. Because now what we're doing is we're going to take this ephemeral data that normally was just in and gone, a decision made in one, gone in the next. These things will start getting recorded and will be available and will be communicated. This will happen. And again, I hear the privacy and security thoughts. I know. The fear is there. Number two, wikis, enterprise data that we know is like our lifeblood of what goes on inside of an enterprise. They're great, but what's the big problem? They're never up to date. AIs will start making self-updating wikis. That is almost a no-brainer. The fact that it will know and understand some versions of truth will help document these things and keep these things up to date. Number three, management reports. Who here likes to write management reports? Like, no hands. Okay, good. This, I think, like when you think about management reports, so like let's just take an engineering example. Well, hey, are we really making our projects? Are we making progress on our OKRs? Well, like I need to go generate a report says, hey, engineer, are you doing your work? Well, let me check JIRA tickets. Let me flow that up into some story. Let me write a report that I hand to my manager, who then congeals a bunch of other reports, who rewrites it again for their manager, for someone to say, oh, it looks like we're doing things, right? Like this is a massive waste of time. And like, I actually think AI is going to be very good at being able to do this. This is the enterprise will change. Number 4, this will take a little bit of reach, but local agents or oracles for every area of expertise. AWS and Amazon is already doing this, right? Where you're going to have a specialized model for AWS that says, I know exactly how AWS works, what it does, the actions that are needed, and I understand your specific environment and the data in your environment, and I can be the oracle of that. I can answer and do questions and give you the information you need. No longer do I need to say, hey, engineer, go figure out what has privileges around this asset. This thing will say, not only do I know what privileges it has, I can tell you down the line who has those privileges, what groups will then inherit in order to have privileges to this access. This will happen. Think about this for identity. Think about this for emails. Think about this for JIRA. Think about this for Salesforce. These oracles are the equivalent of API endpoints, and what will be really fascinating if these oracles can then start talking to each other. Okay. That's what will change. That's my sort of prediction in the organization. The next biggest partner to security is engineering. So what changes in engineering? Number 1, I think code and cloud will become self-documenting. Already AI is way better at doing engineering comments, than engineers are. So if you take a function call and you write a comment for this and say, hey, here's my sort of comments for the function call, and think about that, abstract it to then comments to the classes, abstract it to comments and store around the libraries, abstract that to the application. There is no question that now, anytime an engineer can change code, those stories and comments about how the code worked can be reflected automatically. So you can see a document and documents that are built that will reflect the ongoing changes in that code and how that application works. Similar, of course, with cloud, because that oracle will help do that. I think, you've all seen a lot about Visual Studio and about Copilot and all of the great things that are happening in this world. You're starting already, like when any language, everything's about libraries, the Lego blocks and the building blocks that are built. Coding is all about just how do we glue those things together in order to get what we want. I think we're going to start seeing a real resurgence here around requirements, which today most people don't write requirements at all. And if they do, they never are kept up to date. But when you start getting where requirements are the things that are key for the AI to start generating the code blocks, this then starts getting to requirements as code. Trademark pending. But like this is like, think about this also as, remember Ruby on Rails? Like, oh, it was great because it has this great framework that you can automatically do. Similarly, an example, you're going to start doing this on new projects. You'll start interacting. You'll build a requirements doc. It will kick off new projects in a way better way, and also even modifying existing projects. I also think integrations will be automatic. AI is very good at being able to say, here's a documented API, here are the calls in order to do that. Can you at least generate me a prototype calling client library? It will do a pretty good job, right? Not perfect, but again, we're thinking a couple years here. I think this will just happen automatically. And by the way, if you can self-document the code, you can also look at the APIs, you can create the libraries, and the other AI can use the library because it's an agent. All of a sudden, integrations become way easier. So think about product 1 that should have integrated into product 2. I think this no longer means an engineer writing code. Finally, I talk about localized models as well. Think about this in operations. Like if you go talk to an infrastructure engineer around their on-call and their incident response, they're like, hey, 50% of the time, the way to fix things is reboot it, or respawn the container, kill the instance. Like that is literally these things. This is like, why do you need some junior engineer going and doing this and figuring this out? I think models will run locally, figure this out, and act for you. And think about this at scale across enterprises. Okay, now we've got fundamentals of AI, how it can impact the enterprise and the organizations. Finally, we get to the security portion of the talk. So the CISO's top challenges. This by far is the #1 question I get asked 100 times a day. Hey, Caleb, so what are the top challenges that you have? Hey, what are the biggest issues that you deal with as a CISO? If there are any CISOs in here, you know what I'm talking about. I would ask you to raise your hand, but I don't want to make you a target, so you don't have to. But like VCs and founders and vendors, what are your problems, Caleb? What are your problems, Caleb? So I'm going to answer this question with finality. I'm going to give you the answer to that question that has not changed 5 years ago and will not change from 5 years from now. Are you ready for this? Make sure you get your phones ready. You're allowed to take photo of this because you're going to go to a CISO at RSA and say, hey, are these your top problems? And they go, yes. Are you ready? This is this no more. You don't need to ask this question again. Here are the CISO's top challenges. Reporting, talent, relationships, budget, and management. This are the top challenges. They're not very unique, by the way, to security, oddly enough. There's no real uniqueness to these problems, and they will never change. That's just the way that it works. Of course, listen, this is B-Sides. This is a technical security conference. I'm not going to talk about the real problems of a CISO. I think what we really want to talk about is the top security challenges that we need to deal with. And so these are 6 sort of top security challenges. And by the way, I did not just come up with these on my own accord. I actually talked to over 40 CISOs, and I consolidated that data, and this actually is the consolidation of those conversations. These are sort of the top 6. What's also interesting about these top 6 is like similar to what I just said earlier, that really is not surprising. Like if I said 5 years ago, is vulnerability management a problem? You would go like, yeah. If I asked it 10 years ago, you'd be like, yes. Detection and response, compliance and measurement. Like these are all standard, same problems that we've dealt with 10 years ago that somehow is still the problem today, right? And then so you start like thinking about this, and look, there's a little bit third-party incident management, least privilege. These two, they've always been in the top 10, and they kind of like, rotate in and out of the top 5, but like, why? You have to ask this question, why after 10, 15 years, where we have billions and billions of dollars in products and solutions in this market, these are still the same problems, right? Are these just vendors not solving it? No, that's not true. I think you have to look a little bit deeper. So there's an underlying fundamental problem that I think glues a lot of these things together that makes it so it doesn't matter the vendor product. We can't have substantial disruption on solving any one of these things because of this underlying fundamental problem. So let me tell you what I think the underlying fundamental problems are. I think it's about coverage, I think it's about context, and I think it's about communication. These are the 3 things that today I think really inhibit the ability for us to actually solve these problems at any level of real material ways. So let's double click into each of these. First, let's talk about context. Context is the who, what, where, why, and how of everything that happens. How do I get enough information to make a confident decision about what I'm looking at? This is everything. So let me give you a very high-level, simple example. Vulnerability management, a key consistent problem. Why is it a key consistent problem? Well, let's say you get a vulnerability that pops up. What happens? Well, it is a CVSS-rated high vulnerability. How many people here in security operations go, oh yeah, that's correct? Nobody, because of context. The first thing you say, well, is it exploitable? If it is exploitable, by whom? An insider, an outsider? Is it only by 3 senior engineers in one certain account? Like, everything is about context. Is there compensating controls that are revolved around this? Like, hey, is it only available to authenticated users versus non-authenticated users? How hard and easy is it to remediate is a great question. For example, priority is not necessarily criticality, right? Like it may be a high vulnerability, but I may have a medium vulnerability that is a patch that fixes 70 other medium vulnerabilities that I know who the developer is, and it's a non-breaking change, and he will make it super simple, and there's no testing involved. That goes up in priority, right? So, but people look at this as, well, criticality equals priority. This is context. So when you start thinking about context, this is why every single alert is just not actionable, because you have to ask the context questions. So let's go through a real life example that I have been through and experienced just to bring it home. I picked this one. It's the S3 bucket example. Why did I pick this? Yeah, I know, because every single one of you has experience with this. You've gone through this process. It is the public S3 bucket, which is the bane of our existence. So let's talk about what happened with me. So we get this report, high issue, says, hey, you have a public S3 bucket. We're like, okay, great. First of all, we have lots of public S3 buckets. So how do I know this is one that's not supposed to be public? So the team goes, well, we have a list of the ones that are supposed to be public, right? Like, yeah, I think so. Oh, well, where is it? I think it's in this Excel spreadsheet. Oh, okay, let's go look it up. Open the Excel spreadsheet. This is really what happens. Okay, here are all the S3 buckets that we know are supposed to be public. Hey, when was the last time this was kept up to date? I'm not sure, like maybe a couple months ago. Okay, well, it's clearly not in that list. So, all right, well, then what's in the S3 bucket? So, you know, it's a pretty big S3 bucket. There's a lot of data in it. So you start sampling. Like, let's start looking at the objects in there. And then things start getting a little worrisome. Oh, hey, there's some pretty sensitive data. There's customer information in here. There's PII. There's some sensitive configuration. Oh, there's some keys in this bucket. What in the world is going on? All of a sudden, now it starts going into more incident response mode. And then people start saying, well, who owns this bucket? Where did it come from? How do we disable it? So then we start saying, well, who owns it? Well, okay, well, let's go to our CSPM. All right, CSPM, enter bucket name, nothing. Okay, well, let's go to the infrastructure team. Hey, infrastructure team, do you know what this bucket is? I don't know, I'm not sure. Go into Slack, search all conversations in Slack engineering for bucket name. Oh, here's some stuff that pulls up. Go in Jira, search for Jira bucket name. Oh, here's some stuff that pulls up. And then you start figuring out, okay, what's the picture and what's going on with this bucket? This is context. This is why one vulnerability alert that shows up in a dashboard requires a massive amount of work, which is the iceberg underneath the water. This is why things don't change, because I have thousands of these things and thousands of icebergs under the water that you've got to deal with. This is context, very critical and done with everything. All right, let's go to the next one. Coverage. Coverage. To me, coverage is probably, and I'm going to stick my finger in the air, and this is my only opinion, but I think 99% of breaches are caused because of coverage. I think it's all about the width and the depth. It's not a matter of, do we have the technology to detect it? It's that we weren't there to see it, or it fell through the cracks. This is where coverage makes the biggest impact. Let's give an example. Let's take the S3 bucket example that we just talked about. So of course, what we end up finding, like the team is like, well, how do we not see this? Why is it not in our environment? So here's what we ended up finding. We ended up finding out that an engineer took their corporate credit card, signed up for an AWS account, launched this S3 bucket as a prototype partnership with our partner just to test it out. They just wanted to test it out, but of course, we all know this. Testing turns into prototype, turns into V1, turns into V2, and that bucket never changed. And the bucket never got incorporated into our account. It just ended up becoming used with our partner as its transfer mechanism. Well, what's really fascinating about this is, as a security team, we're like, well, hey, we have SCPs that say you cannot have public S3 buckets unless you go through our ticketing process, which, ironically enough, is the exact reason that caused this. Because the engineer is like, well, hey, I'm just testing this to see if it works right. Like, I don't want to go through the process of getting security to approve this thing. It's painful. I'm just going to go over here and shadow IT this thing. And this is now the width of why coverage is key. Now, we would have never seen it. It was never part of our environment. It was never part of our rules. It went out of band. Here's where it becomes even more interesting, depth. Well, in that S3 bucket, there was huge amounts of data. In fact, as we were going through it, we identified an engineer accidentally uploaded their entire home directory into this S3 bucket. This is not a joke, people. This really happened. I'm not making this up. Their entire home directory was in this S3 bucket containing all of the source code, all of the keys, all of the access. This thing was everywhere. And of course you start going, well, did anyone access the keys? And then your next question was, well, how do we determine that? Does this S3 bucket have logging on it? Well, no, of course not. It's in this thing. There's no log on. And even if we did have logging, we wouldn't have object level logging because that is just, you can't do that. The performance and cost is way too much, right? Now that's an example of depth. Why in the world shouldn't I have logging on every single access on every single object? Well, it's just too intense, too much, too expensive. It just can't do that. I missed the incident. I missed the content because of the depth, the coverage problem. Okay, by the way, there's so many examples of coverage. I could give hours of conversation on this, but I just want to do a few more. Let's take, for example, account takeover. I have a policy that says all employees mandated 2FA. How many people? That's a good policy to have. We should make sure we do it. Are we doing it? Yes, absolutely. Hey, what happened is one of our social SaaS engineering platforms got an account takeover, and that person was in the account, and we figured it out. And I'm like, well, how did they do an account takeover? Don't we have 2FA? How did they bypass the 2FA? Oh, well, unfortunately, these were some contractors that we made an exception to. Coverage fell through the gaps. Okay, well, hey, we're doing post-mortem on a security incident. How did we not see the lateral movement of this guy doing this to go do this? Well, we're missing the logs. Or even worse, the fields or the events that we needed were missing. Well, why can't we do a detection of this? And I'm going to give you a real example, a very popular software. Well, we can get events for login failures, but there's no event for login success. So that means we can't look to see if brute forcing and a successful brute forcing, right? So, well, who logs login successes? No one's going to log that. Like happens millions of times a day, right? Or here's another one. Well, I thought we were getting logs from there. What happened? Oh, well, the logs stopped being sent to us like a couple quarters ago. Well, what happened? I don't know. Like we're just no longer getting the logs anymore. This is coverage. And my final one, I won't go through all of these, but the final one is, how many of you have the thousands and thousands of vulnerabilities that are medium and lows, or in your SIM or detection response system of alerts that are mediums and lows that all need to be triaged? And you will not do medium and low triage because you just don't have the time. You don't have the resources. And yet we all know the attacks happen through a combination of medium and lows. It's never the high that the attacks occur. It's always the combination of the medium and lows. So it's highly likely that most attacks who did occur, you actually saw it. The event was there. It's just no one looked, right? Okay. Last but not least, before we start getting to the fun stuff, communication. This is the most important and biggest waste of time. And you might say, Caleb, man, come on, it's a little rash to say it's the biggest waste of time. But let me give you some examples. First of all, your manager, or let's say me as the CISO, I come over to you and say, hey, how are we doing on these OKRs? How many of you had that question asked in your doing? Yes, of course. This is your status reports that you need to go write. And then what do you have to do? You have to go and say, okay, I need to talk my manager, to talk to other people, to talk to ICs, to write their tickets, to do their stuff, to manage these things in reports. We talked about this a little bit earlier. I would say 20% of any team's time is probably spent basically justifying their existence. Am I actually doing work or am I not? That is what's happening. And it goes up the stack because the CISO needs to do it for the CEO needs to do it for the board. Like it all just is levels of abstraction of reporting. What if I ask a question like, what is the risk of this asset? Well, actually, in order to get the risk of an asset, that requires a lot of work. I actually have to go into my CSPM, DSPM, ASPM, IAM in order to generate reports around one particular asset because none of these products talk to each other. One asset both is an application, it has data, it's in the cloud, it has privileges. Why do I have to go to all these separate products to generate data in order to mash it up, to hand it over to you so you can look at this and say, okay, it looks okay. Right? It's super painful. And of course, like, why did we not fix this issue? Hey, we reported this to engineering. Engineering said that it was going to be fixed, but yet we retested, it clearly wasn't fixed, the issue is not closed. What happened? Oh, well, engineering didn't know that was a high priority, so they just they scheduled it for next release. Well, wait a minute, this is a huge high priority. How did they not understand that? And why did we get this notification only after this has happened? Well, none of the communication happened, right? Or finally, how can we trust you? Okay, well, there's a vendor. Okay, well, as a vendor, I'm going to send you a big, long Excel spreadsheet with a bunch of security questions. You're going to fill that out, and you're going to lie to me, and you're going to send it back to me, and I know that you're lying to me, and I'm going to say, okay, so we can CYA for legal, right? This is terrible, right? This is communication. Why? How is there not a way that which you can distinctively say, here's a way that you can trust what I'm saying, right, in the right way, without you also offering it to be a security risk? This is all about communication. And to me, communication is about translation, right? It's about translating a version of the truth to another thing or another person, whether it be reports, whether it be system to system, whether it be auditors, regulators, partners. It's about translating some version of truth or quote unquote truth into different audiences. Okay, so now we've talked about the three: context, coverage, and communication. So what do we do about these? This is where I think AI works really well. So if you think about what we talked about previously, where we were looking at how did AI work? What are the things that it's good at? It's good at translation. It's good at synthesizing data. It's good at being able to act and do tasks. These are things. So let's take coverage, for example. What would you have 10,000 smart junior security engineers do? Or if you remember the beginning of my slide, really smart 13-year-olds who have a patience problem. But what would you have them do? If you had 10,000 of them, let's take an S3 bucket, for example. I would absolutely have that engineer go through every single S3 bucket object. I would absolutely have that engineer go through every medium and low triage event, right? And by the way, this is not fake. There are companies today that do this, right? Triage becomes a non-existent problem because you have such level of scale, all right? I would have them go through and say, every single engineering discussion, is there something security related in this? Every requirements document that's built, is there something security related to this? Every code that is committed, what's going on here that can affect security? 10,000 can now increase and make substantial material difference in the way that you do coverage. That is a massive, massive difference. Context. This is the hardest. But I also think is one of the things that is very, very doable today, which is when it comes to context, I can actually have oracles of information, and these agents can go talk to other agents and pull that information out, synthesize it properly, and then present it. Communication, everything is just about the ability to effectively communicate it to the right audience. Take data, synthesize data, format it, and translate it for the right people. And by the way, chat ops is back. This is very doable with AI in a real way. If you need context, you can just Slack the actual engineer, AI can Slack, and have a decent conversation with that engineer and ask follow-up questions and get data, synthesize that data, and send it back to you. This is doable and is being done today, right? This is where it makes very significant changes. Okay, now, what I want you to do is take a little bit of a journey with me. And let's say, now that all the things that we've learned, how would this show up tomorrow? So I'm going to go a little bit of what we see today, and then how should this look like tomorrow, assuming context, coverage, and communication are pulled together properly in AI in the next year or two. All right, so today, I sit down at my alert console and I get a detection alert that says a new outbound call to stripe.com was identified. And you look at that and you go, yeah, that's pointless and useless. Is it supposed to? Again, context. What's who, what, where, why? Well, what happens tomorrow? Tomorrow, this changes. It is now being allowed. Oh, that's interesting. This is expected behavior and is considered low risk for the following reasons. Number 1, Stripe is a trusted provider and outbound calls are only allowed. Number 2, engineering documentation and discussions have identified Stripe being the new accepted payment provider. Number 3, the Stripe libraries were introduced to the code repo payment lib on this date. Number 4, a discussion with Cosmo, who is the active contributor to payment lib, occurred at this time frame via Slack, and he did confirm stripe.com as a domain should be allowed. Wow. Guys, like this is, come on, like, wouldn't that be amazing? Wouldn't this be amazing if this could happen? Let's do another one. Vulnerability management. Today, we get a cross-site scripting issue was identified in our internal CI system via the case commenting function. Great. What about tomorrow? Well, it's located here. The total exposure time was 22 minutes. What? Well, that's interesting. At this time frame, the issue was identified via the nuclei assessment that was done. And here is the bolded part, by the way. The issue is rated low risk due to internal system, limited authenticated users required, and on a staging system. Wow. This is doable. This is totally doable. The issue was then introduced in the last push to staging. The code that has the vulnerability was found to be introduced by Josh Smith. A fix with a PR was submitted, and Josh was notified via Slack. Josh has recognized this issue and has accepted the PR. A new rule was added to SemGrep, and the requirements doc was modified for this type of issue. That's fantastic. Now I can just, like, I'm going to go, like, hang out with my kids. Job's done. Let's do one more. Your requested approval settings are high for any crown jewel trust zones. A request for delete access for role SP report gem on S3 bucket, this bucket, do you approve? How many are familiar with this? How many of you hate this process? It's terrible. Well, do I approve? Do I not approve? Do I delegate? Like, I don't, even the people who are delegated to the experts still don't know whether they should improve. What does it look like tomorrow? Our recommendation is to grant access for the following reasons. This request was made by Martin Bryce, who is the principal engineer of the data infra team, who has ownership of this asset. Oh, that is context. That makes a big difference. Meetings with Martin and the business media team discussed cleaning up and discarding reports on a regular basis on this date. Oh, okay, that adds some more value to this. JIRA ticket 2928 was filed with a request for expanded permissions for regular cleanup activities. Okay, also very good. The requirements doc for the SP report gen role was added to have delete capability. And finally, we reached out to Werner Brandes, who is the head of security engineering via Slack at this date, who also says he gives his approval for this. You know what? Absolutely approved. Move on. And then, like, last but not least, status reports. For example, I have a very simple ask. I have a set of crown jewels, and in my crown jewels, I want to do least privilege. And all I want to know is, hey, how many accounts have been reduced? And I want to know, of the accounts that have to be there, how many privileges have been reduced? That's it. And all I want to know is, on a day-to-day basis, are these things getting lower? And that doesn't require people to go do work. That just requires an automated thing to do the right, pull the right data, which is easy enough, translate that for me, and produce what I have here. Okay, so I hope you've enjoyed sort of this journey. I look forward to all the startups that might come out of this and maybe make our journey a little bit better. Okay, thank you. Any questions? How much time? I had 3 minutes for questions?
Your 3 minutes for questions.
Okay. Are there any?
There are some, but I was not ready to read them because you said you would.
Oh, okay. With 3 minutes, I could probably answer one question. So
All right.
I'll do that.
One question with upvotes. What are some potential real-world challenges using quantum computing with artificial intelligence?
I have no idea. I am not knowledgeable enough about that subject. I don't know. So I guess that is the answer to that question.
All right, fantastic. Thank
Okay.
you so much, Caleb.
Thank
We
you.
really appreciate you.